Okay, so a hyperbola. Okay, remind me what we knew about hyperbolas after that first day, what we came up with. Well, what's something that sets it apart from the other conic sections? There's two pieces, right? There's two pieces, one on the left, one on the right, or one on top and one on bottom. Okay? So a hyperbola has two different pieces. All right? Let's go ahead and define the hyperbola geometrically, and then we'll look at the equations and start talking about it algebraically. All right? Look on your formula chart, if you will. What's one of the first differences that you notice between the ellipse formula and the hyperbola formula? It's minus instead of plus. Okay? So in that ellipse, the constant distance was, the sum of the distances was constant. Okay? In a hyperbola, our definition is the set of all points such that the differences of the distances to two fixed points is constant. The differences is what accounts for that minus sign in a hyperbola formula. Okay? How do we form hyperbolas? Good. When the plane is perpendicular to the bases. Okay? You have to have a double cone to get a full hyperbola. And when the plane intersects the double cone perpendicular to those two bases, we will get a full hyperbola. Okay, questions on any of this? I think we'll still have a hyperbola. I think we'll still have a hyperbola. I think the important part is that it's perpendicular. It's both of those. The bottom piece might just be like really, really small or just a point or something like that maybe. I don't know, but that's a good question. Okay, you done copying this down? Okay. As we go through, we added our formal definition of ellipse. Now you have a formal definition of a hyperbola. I would recommend you going back to that first sheet we got when we first started conic sections so you can have all your formal definitions in one spot. Okay? All right, let's look at our formula chart. So we said one of the things we notice is that there's a subtraction, okay, between the two terms. What else are some things you notice? Carly? Good. In a vertical hyperbola, your y terms come first. Okay? In ellipse, they always were second. Now in a hyperbola, sometimes you're going to have x terms first, sometimes you're going to have y terms first. And that's going to tell you horizontal or vertical. Other ideas over some of the stuff that's different? Or the same? There's a what? Yeah. Okay, so this is our formula relating our a, b, and c. This is different. In a hyperbola, it's c squared equals a squared plus b squared instead of a squared minus b squared. Okay? That has to do, look at your picture. Where are your foci located? Outside of the hyperbola. Okay? They're on the outsides of your vertex. In an ellipse, where are your foci located? Inside. So that's why it was minus, and now for a hyperbola, it's plus. Okay? Look at the graph. Talk to me about some differences on the graph.
The center is 2 lines running through it.
Okay, what are those 2 lines running through the center? What do you think those act as? Those are going to act as our asymptotes. Okay? If you look, our curve tends towards those diagonal lines. Those are our asymptotes. Okay, so a hyperbola has 2 asymptotes.
The foci or foci are like instead of being in between vertexes on the outside.
Yep, the foci are on the outside. All right, so I've written some of this down for you so that you can make sure that you have it. Okay? In a hyperbola, A, B, and C mean the same as an ellipse. What did A mean? Good. Distance between the center and the vertex. What did B mean? Good. Center and co-vertex distance. And what about C? Center to the focus. Okay? In a hyperbola, your A value is always listed under the first term, whether it's X or Y. Okay? It's always under the first term. The other way you can think of that is the term that's positive. The term that's not being subtracted. Okay? One major difference here is that A doesn't have to be bigger than B. It just has to be under the first term. A does not have to be bigger than B in a hyperbola. Okay? And where A is determines horizontal or vertical. All right. The other difference we had already mentioned was that C squared equals A squared plus B squared. In an ellipse, that's A squared minus V squared. Okay, so that's different. We talked about that on the graph. There are asymptotes. Okay. Okay. In an ellipse, we had major axis and minor axis. Okay. But in an ellipse, the major axis always connected your vertices, and that's always longer than your minor axis. Okay. We always have one longer than the other in a hyperbola. So we use 2 different words, transverse axis and conjugate axis. Okay? The transverse axis, that connects your vertices. Transverse axis connects your vertices. The conjugate axis connects your co-vertices. What would be a good way to keep these separate? Yeah, that's CO right here. CO, CO. Conjugate axis, co-vertices. Okay? You got to know which one's which. Got to be able to keep those straight. All right. So, with our formula charts, we are going to go ahead and do some graphing. So, we're going to start with a really simple example. Okay? The graphing of a hyperbola has a lot of steps, so it's going to be really important that you keep your work nice and neat and you follow along with the steps. You might even, as we're going along, write yourself kind of what you did, step by step. That's what I did on my notes. I wrote what I would do first, second, third, fourth. Okay? All right. X squared over 9 minus y squared over 4 equals 1. Okay, so first thing I want us to do is I want us to decide, is this a horizontal hyperbola or a vertical hyperbola? Horizontal. How do we know? X comes first. This is a horizontal hyperbola because X is listed first. Okay? All right. So that means, let's decide what A and B is. What's A? A is 3. It's always under your first term. What's B? B is 2. Okay? What's my center? 0, 0, because I don't have x minus something or y minus something. So my center is 0, 0. All right? So let's go ahead and on our grid, I want us to go ahead and plot our center. My center was at 0, 0. Okay, if A is 3, what does that tell me? Center to vertex. So am I going to go left and right 3 or up and down 3? Left and right. 1, 2, 3. There's a vertex. 1, 2, 3. There's a vertex. So what are the coordinates of my vertices? Negative 3, 0, and 3, 0. Good. All right. Co-vertices. I'm going to go up and down how much? 2. 1, 2. There's a co-vertex. 1, 2. There's a co-vertex. So those are at 0, 2 and 0, negative 2. All right. Now we want to plot our foci. Okay? So in order to find my foci, what's the equation I use? C squared equals A squared plus B squared. So C squared equals, what's A squared? 9. What's B squared? 4. So C equals square root of 13, which is between what two values? 3 and 4. So on my grid, I'm going to count out a little bit more than 3. I'm going to plot my foci, count out a little more than 3, and plot my foci. Does that make sense? Does that placement make sense? Good. Why? Based on your formula charts. It's outside of the vertices. Harry?
How do you figure out what two values the square root of a number is?
So this is between the square root of 9 and the square root of 16, right? So it's a little bit bigger than 3, but smaller than 4. Okay? All right. So what are the coordinates? Oh, sorry. Remember that your foci are still in line with your vertices. That's the same as an ellipse. Okay? They go on the same line as your vertices. That's why I plotted them on that axis. Okay? All right, what are my coordinates of my foci? Yeah, so I could do plus or minus root 13, comma 0. Because I go positive root 13, 0, and I go negative root 13, 0. Okay? So our first step was to plot our center, our vertices, and our co-vertices. Our next step was to plot our foci. Your third step, okay? Your third step is we are going to draw in that box that you see on your formula chart, okay? This box, draw it very lightly, okay? It's not really part of the graph. It's there to help you graph. The box goes through your co-vertices and your vertices. Your box goes through your vertices and your co-vertices. Okay? All right. Next, we're going to draw in our asymptotes. Okay? Your asymptotes go through, they're always going to go through the center and through the corners of your box. Okay? So I'm going to draw in my asymptotes. They go through your center and through the corner of your box. Okay? So now you're going to draw in your curve. Look at your formula chart. Where does your curve start on either side? The vertex. Okay? So from your vertex, I'm going to draw it so that it tends towards your asymptotes. You will never cross these asymptotes. Okay? You always want to double check. I decided this was horizontal. Did I actually draw a horizontal hyperbola? Yeah. Okay? Questions about any of that? Like I said, lots of steps, but if you keep yourself organized, you'll remember the steps. Okay? All right, last thing we want to do is we want to find the equations for the asymptotes. All right? Use your slope, use your center and the corner of one of the box to find your slope. We went up how many? Up 2 over 3. And in this one, I went up 2, left 3. So what are your two slopes? 2/3 and negative 2/3. So your slope is plus or minus 2/3. Where have you seen those numbers 2 and 3 before? Yeah, it's our A and B. Your slope will always be A over B or B over A. Okay? It'll always be A over B or B over A. All right? And what's a point that this line goes through? 0, 0. So this is an easy one. We don't have to use point slope, right? Because there's no y-intercept. So what are our two equations? 2/3 x and negative 2/3 x. When you do have a y-intercept, when your center is not on 0, 0, we'll just use point slope there. Okay? All right, let's try another one. Y minus 3 squared over 16 minus x plus 1 squared over 25 is equal to 1. Okay. First thing I want to decide. Is this a horizontal ellipse or a vertical ellipse? This is a vertical ellipse. How do we know? The y comes first. The y is our positive term. Okay. In a vertical ellipse, you have to be very careful deciding on your center. Look at your formula chart. Your center is always h comma k. Okay? Your center is always h comma k. And h is always paired up with what variable? X or y? X. And k is always with y, no matter the order. So, what is our center here? -1, 3. Do you see how this is an easy mistake to make? To turn your center accidentally into 3, -1? And unfortunately, guys, it's all gone after that. If you don't have the right center, your vertices aren't going to be in the right spot, your co-vertices, your asymptotes, nothing's going to be in the right spot. Okay? So you've got to be really certain that you are doing your center accurately. Okay? Leah, did you have a question? Okay. All right. Let's decide A and B. What's our A value? A is 4. A always comes first. What's our B value? 5. So let's plot this. -1, 3 for my center. All right. What does A tell me I'm going to do? Go up and down 4. 1, 2, 3, 4. And what's located right there? That's a vertex. Good. And down 4. So what are the coordinates of my vertices? Good. And -1, -1. All right, co-vertices, I'm going to go left and right. How much? 5. Now, is it okay for a hyperbola that my co-vertices are farther apart than my vertices? Yes. Okay, that is okay. All right, so left and right 5. What are our coordinates for co-vertices? Good. Not 5, 3. 4, 3. All right. So we've plotted our center, we've plotted our vertices, we've plotted our co-vertices. What do we plot next? The foci. The foci. And what's the formula we use for foci? C squared equals A squared plus B squared. So C squared equals 16 plus 25. What is 16 plus 25? 41. So C equals square root of 41. All right, so which direction am I going to count for my foci? Up and down or left and right? Up and down. How do we know? Same directions as my vertices, and this is vertical. So square root of 41, that's between what and what? 6 and 7. So 1, 2, 3, 4. So I need the coordinates of my foci now. Very good. Okay, now what can we do? Draw our box. All right, once you draw in your box, then what? Your asymptotes. And how do you know where your asymptotes go? Through the center and through the corners. Good. So through the center and through the corners. All right, and how do I finish drawing the curve from here? Good, start at the vertex and follow your asymptotes. Okay? What's our last step? Find the equations of the asymptotes. All right, so let's find our slopes. So from your center, how many did we go up? And over 5. So our slopes are plus or minus what? 4/5. And what's the point that we're going to use? The center. Yeah. And what's our center? -1, 3. All right. What was that point slope formula that we can use? Y minus y1 equals m times x minus x1. Okay? All right, so let's start with positive 4/5. So y minus 3 equals 4/5 times x, what? Plus 1. So y minus 3 equals 4/5 x plus 4/5. What do we do next? Add 3. So y equals 4/5 x plus, what's 4/5 plus 3? What do we think like we're adding to 4/5? 15/5. So what do we get? 19/5. Nope. You can't just put plus or minus in front of your slope because it's going to change your y-intercept. They're going to have two different y-intercepts. So you're just going to run through it real quick with a negative 4/5 x. So this is y minus 3 equals negative 4/5 x minus 4/5. What do we still add to both sides? 3 or 15/5. So y equals negative 4/5 x plus 11/5. And those are your two asymptotes. Okay? All right. As you can guess, you do not always get your hyperbola in graphing form. Okay? So, if we're given it like this is called the general form. Okay? If we're given it like this, what do you think we're going to have to do? We're going to have to get the positive one first, and then we're going to have to go through what process? Completing the square. Okay? It's okay. We can do it. All right. So, whichever one is already positive, whichever y squared or x squared is already positive, keep that one positive. Okay? So, which ones am I going to list here first? My y's or my x's? My y's. So let's group. I'm going to have y squared plus 4y minus 4x squared plus 24x What should I do? Excuse me, what should I do with that 41? Move it to the other side. All right. Now we need to get ready to complete the square. Okay? So y squared plus 4y. I'm going to leave a blank here. What do you think I'm going to have to do here? Good. Pull negative 4 out. So I'm going to pull out minus 4. Inside my parentheses, what am I going to have? Good. This is one of the easiest places to mess up right here, guys. If you forget to pull the negative out of that middle term. Okay, so be really, really cautious of that. Plus blank equals 41 plus blank. All right, let's do some half boxing and squaring. So if I take my 4, I'm going to half it. I get 2. What do I do next? Box, then square, and I get 4. So if I add 4 here, what do I add to the other side? 4. All right. Next, I'm going to take this negative 6. So negative 6, half it, what do we get? Negative 3, box it, square it, what do we get? 9. So I add in 9 right here. Okay? Now, what have I really done to this side? Not 45. You multiply the 9 by negative 4. So really on this side, I have added a negative 36. Remember, whatever you do to one side, you have to do to the other side. So if this side I have put in a negative 36, what do I have to do over here? Subtract 36 or add a negative 36. Okay? Just like if we add 4 on one side, we have to add 4 on the other side. If we subtract 36 on one side, we have to subtract 36 on the other. Okay? So, what does this become? Y plus 2 squared minus 4 times x minus 3 squared equals, this remember, without calculator, 41 plus 4 is 45 minus 36, 9. All right, we're almost there. Yeah, so we have to get it equal to what? 1. We've got to get it equal to 1. So we're going to divide every term by 9. So this will become y plus 2 squared over 9 minus x minus 3 squared. What is that going to be over? This goes back to our discussion yesterday. 9/4. Good. We divide by the reciprocal. So I put my negative out here because that's how our standard forms look like. This, okay, but this is a minus. Thank you. Cool. Do we know where that class is? Okay, so this right here is y plus 2 squared minus 4 times x minus 3 squared. This is not a negative 4. Okay, it's the same idea, but it's a minus. Just like in ellipses, we put a plus here. Okay? All right. Is this ellipse horizontal or vertical? Vertical. What's the center? Good. 3, negative 2. Okay? I understand it's so easy to do. I did it a lot. Okay, so you've got to be really thinking about it. You've got to make sure you're not doing that. The center here is 3, negative 2. What's your A value? A is 3. What's your B value? 3 over 2. Okay? I'm going to go ahead and stop here because you have 2 full examples of graphing. Okay? Is that okay with you guys? Yeah, I figured. All right? So, I will pass out your homework. Your homework, again, is for tonight and tomorrow night. Okay? When I give you your homework, the first set, the ones for tonight, are meant to be done on your own paper. We did not leave you enough room. Okay? So, you need to do your homework tonight on your own paper. Tomorrow night, you can write it on the sheet. Okay? Everyone understand?